Hi, I'm Sean, and this is part 2 of this series on robots, operating systems, and robot operating system. So in this one, we'll be talking about operating systems, specifically in the context of robotics. What's the de facto standard operating system in robotics, and what are some important programs for working with robot computers? So before we get into the operating systems used in robotics, let's first talk about what an operating system is. So this is what you usually call OS, so that's like Windows, Mac OS, or for mobile devices, Android, iOS, iPad OS. But the user interface is, while the most noticeable feature of these operating systems, it is not the key feature. So usually in your day-to-day, what clues you into what operating system you're using is what you see, the user interface. And this drives a lot of the opinions on operating systems when you're, say, choosing what computer you want to use or purchase. But really, the important thing that matters, at least still for software development, is what's underneath. The operating system manages hardware, it schedules tasks, schedules programs, allocates memory, and a lot more. All operating systems do basically the same fundamental things, but they go about it differently. It's like comparing a diesel engine and a gas engine. At the end of the day, they help you rotate your tires, but they're based on a different fuel, for example. They're configured differently. So one of the most popular operating systems in the server space, but not necessarily in your personal computers, is called Linux. And Linux is actually a family of operating systems. It's Unix-like, so Unix was an early operating system. It's not very popular anymore. It came out of Bell Labs. And a lot of operating systems based their structure off of it. So if you're a Mac user, for example, your file structure is Unix-like. It's set up to be similar to this Unix operating system. And Linux is very similar in that sense. Linux is free and open source. That means the source code is available and you're able to modify it and distribute it as you like, so long as you're complying with the license, which is basically if you distribute your copy of Linux, your modified copy of Linux, you also have to distribute your source code with it. It's also free as in terms of money. You don't have to pay money to download Linux. You can install it for free. And again, the key thing differentiating different versions of Linux is not the desktop environment, though that is the most noticeable component. It is more so what's lying underneath, the tools that it comes with. So these different versions of Linux are called distributions, and they're maintained by different groups. Some companies are such as Canonical or Red Hat, which is owned by IBM. Now, Ubuntu, which is maintained by Canonical, is the de facto standard for academic robotics. It is the one you will see the most, and the one we're going to be using in our group. Now, a quick aside, Linux was developed by Linus Torvalds originally. It's got a lot more developers since then. Linus is also the creator of Git, which is the version control software that we use. So, Ubuntu is on board all of our robots. In robotics, it's become a de facto standard. We use 22.04 as of now, so that version means it's from April of 2022 essentially. It's a long-term support variant, so we don't have to upgrade for a while. And we use Ubuntu both for development on our personal machines and deployment on our robots. Now, you might be wondering how you can get it on your computer. You're running Windows or Mac. You might not want to flash your operating system because it's a bit risky. It can erase all of your files. So there's some things you can do. One thing you can do is dual boot. You can split the hard drive on your computer into two separate locations, and you can install Ubuntu on the location you free up. So you can have Windows or Ubuntu, and you can choose it when you start your computer. This might be a little bit harder for, say, ARM series Macs, such as the M1 or M2 or M3 Macs. So in that case, you might want to use a virtual machine. So a virtual machine is like having a virtual operating system running on top of your main operating system. So some software that's used for this includes VMware or VirtualBox. Another option for Windows users, and this is slightly different from your standard virtual machine or VM, and it's called Windows Subsystem for Linux 2. The 2 is important. It essentially adds Linux onto Windows on the side. And another thing you can do is use these things called Docker containers, which are also kind of like a lightweight virtual machine. Now, there's more details about all of these options in the QR code, which leads to our Notion page. But you'll have to do a bit of research on your own because everyone's situation is a little different, and I can't really cover that in this presentation. So I mentioned earlier, Linux is a Unix-like system. That means its file system, or the folders that everything is in, is similar to those in the original Unix systems. And there's a lot of folders. I won't cover them all, but we'll go over some of the big ones. So slash. Slash is the root directory. Now, directory is just another word for folder. So the root, or slash, is the area under which all other folders are. This is kind of like your C drive on Windows. Now, slash mnt means mount. This is where you'll put your external media. So if you have a hard drive plugged in, it'll probably be under mount. etc. or etc. It has system configuration files. OPT is option. This is where the add-on software you install goes. It's kind of like programs on Windows. And then home. Home is the directory you're going to be most concerned with. Home is where you start. Home is like the users folder on Windows. And inside home, there's actually a folder with your username. So /home/username is basically where you'll always start. And that's sometimes abbreviated with the tilde symbol. And now these are all folders in the root directory, and as you get deeper and deeper, it's going to vary more and more, just like any operating system. The shell is the place for writing commands. You might know this as terminal or command line. You have one on Windows, Mac, and of course Linux. This is how people worked with computers before graphical user interfaces came about. So on Windows, you'd be familiar with, say, CMD or PowerShell. On Mac, you're probably familiar with Zish or Z Shell. And Linux is usually Bash or Born Again Shell. So we'll go over some of the commands you use to navigate the shell in a moment. Just want to let you know that Linux also has its own way of managing privileges. So on Windows, you often have to go into admin mode to install things, right? So on Linux, you have a thing called the root user or super user. And when you want to go into that admin mode, you'll often run a command with sudo in front of it. Now, sudo is very powerful, but that's also very dangerous. So when you use it, make sure you know what you're doing. All right, so going into the shell, let's start with where are we? When we open a shell, usually we'll be greeted by something that looks like username at hostname $, $. That is telling you that you are currently in the folder /home/username. and you were logged in as the user specified by the username on the computer which has the host name. Now, the space after the colon, that is telling you where you are. So, or the path. The path is a description of the location in the file structure. And usually what's given to you is the relative path from tilde or /home/username. I know I'm just throwing a lot of words at you, and it does get much easier when you actually start using it. I would play around with the shell and just refer back to these slides. So we're going to talk now about our first command, pwd, print working directory. This tells us where we are absolutely. When you type pwd and then hit enter, you should get an output that looks something like /home/username/folder, depending on what folder you're in. This is the absolute path. This is where you are in the entire system's file system. Now that we know where we are, we need to think about where we want to go. Thinking about that sense, think, and act, we are now thinking. So you can use ls to list the directories in your current directory. ls-a will tell you all the directories and files, even hidden ones. So say, for example, you've got a folder. You'll see, when typing ls, you'll see folder A and then like this test.txt text file. But you won't see .gitignore because it's preceded with a dot, meaning it's private or hidden. When you do ls-a, those hidden files will become apparent to you. So try it out on your own system, see how it works. All right, now that we've seen what is in our current directory, we can use the cd command, or change directory. We can cd to a relative path. Say we've got a folder called folder A. We can just type cd folder A and go there. We can also use an absolute path. So if you have a slash at the beginning of the directory you're specifying, it will navigate to the absolute path. Also, let's say we want to go up one level in the directory, we can do cd ... Again, try it out. All right, now we're going to talk about something different. Package management. So on Windows, you're probably familiar with .exe style installation. In Ubuntu and Linux, these sort of files do exist, but they're not very popular. Instead, you use what's called a package manager. And on Ubuntu, it is called apt, which some people might pronounce as apt. I'm going to say apt. So when you're working with a package manager, usually you'll want to use these commands. So sudo apt update will update the database. It'll go and look at all the packages that you have available, what you have installed, and what's available to upgrade. Then if you run sudo apt upgrade, it will actually upgrade your installed programs. Sudo apt update does not update your programs. Sudo apt upgrade will update your programs. And then sudo apt install installs a package. Sudo apt remove uninstalls the package. All right, so now thinking a little bit more about robotics, you usually have a computer on the robot, right? And you're going to want to be able to see what's going on that computer. So that's why we have a thing called secure shell, or SSH. And usually the way you go about SSH is you have SSH and then a username at the computer's IP address. And we'll go into this a lot more later on, not in this presentation. But if you're part of the Marine Robotics group, we'll definitely get to it in person, and hopefully we'll have a tutorial about that somewhere in the future on YouTube. So this is how we remotely log in to computers, say on the robot, and see what's happening on board. It launches you straight into a shell session. Another tool we have is called Terminal Multiplexer, or tmux. tmux is a program that lets you split up your terminal and it runs on whatever computer is hosting your shell. That means if you're SSH'd into the remote computer and you type tmux, it's running on the remote computer. Now, why is this useful? So when you're working with a remote computer, sometimes your network goes down and then your shell disappears. And when you log back in, it's completely gone. Anything you had running in that shell is terminated a lot of the time. So using tmux allows you to both detach and reattach to those sessions. So even if you lose your connection, you can just log back in and reattach so you can see what you were up to and continue having your processes run even if you disconnect. tmuxp is a Python-based tool that actually lets you load tmux sessions from config files. So if you have a whole set of terminals that you just want to automatically run with one command, this is a good tool for you. So we've covered a lot, and it's not even scratching the surface. But in general, from this, you should know that operating systems are what help orchestrate robotic programs. Or not help, they do orchestrate them. Ubuntu is the de facto OS for robotics, and we use it in our group. And you're going to need to learn how to use the shell in order to run robotic programs. You'll want to know how to install packages, remotely control computers, and monitor programs. Now, in the next one, we'll be talking about robot operating system and what that means for developing programs on robots.